All right, so let's jump right into these advanced rules, the two that we're going to talk about here. And I'm going to call them rules 5 and 6 in the notes because they follow right after the first four that we just discussed in the topic 1 video. So let's come to our blank sheet. And in this case, I'm actually going to write out both rules and then we're going to do an example of each. So in the last one, I did any examples we needed to look at as I went along, but this time I want you to compare them side by side. So the first one is called the product rule, and the second one is called the quotient rule. So that's going to be product rule is for multiplication and quotient is for division. So not too crazy there. I'll use a separate color here so we don't get confused. And here we go. So the product rule says if I am trying to derive two different expressions that are being multiplied, so remember we said u and v we often use to represent two separate functions, like with respect to x, but they can be really ambiguous. They can be anything. It could be power function, it could be a trigonometric function, it could be a 1 over x type of function, a rational function, doesn't matter. But I want to erase that extra dot there. So u, when I say u and v, I mean two different expressions with respect to x. So if I'm taking the derivative of u times v, I can find the answer as long as I follow this pattern. And the pattern is this: v times u prime plus u times v prime. V is going to be whatever, or u and v are going to be whatever the original functions or expressions are, and u prime and v prime are going to be the derivatives of each of those separately. Now, if that looks a little bit suspicious, just hold on a moment and we'll look at an example. But let me give you the quotient rule as well so you can see how they are related. So the quotient rule says if I want to take the derivative of u and v but not multiplied, I want to take the derivative of u over v, I can figure out what it is by following this pattern. V u prime minus u v prime, so same pattern except it's subtraction instead of addition, but all over v squared. So v u prime minus u v prime all over v squared. That's the quotient rule. Let's see how that works in an actual example problem. So let's say I have one I've written down here. Okay, we'll do the derivative with respect to x of x plus 1 times 2x squared. So we're taking the derivative of this whole expression. This fits the product rule because we have a u and a v. So we'll call this u and this v. Here's how I like to organize my problem when I'm solving these. I like to write u equals and v equals, and then I give myself a space to fill that in, and then I write u prime equals and v prime equals, and I give myself space to write. Let's fill in that information. U is x plus 1, because it's that first portion. V is 2x squared. So when they're by themselves, they actually don't look that bad, right? Normally, prior to this, to learning this rule, you would think, oh, I need to factor this whole thing out before I can derive it, because it doesn't fit some of the other patterns of like adding and subtracting. We have multiplication. But you don't have to multiply it all out. There's a pattern and a rule for it, and it's the product rule. So let's derive each of these separately. The derivative of x plus 1 is really, we can look at each of these separately, remember, because they're added. The derivative of x to the 1 is just 1. So x to the 1, you'd swing the 1 to the front, and then you'd lose the x. x, right? X to the 1 goes to the front, and it would be 1 times, x to the 0. X to the 0 is just 1. So derivative of x is just 1. Derivative of a constant, 1 is a constant, is just 0. 1 plus 0. Or, that's redundant, we're just going to write 1, because that's all we need to say. So the derivative of x plus 1 is 1. You can slow that down and repeat it if you think I went too fast on that. But that's just the power rule and the constant rule. Derivative of v. We're doing it separately, right? We're not even using this formula yet, which is going to tell us vu prime plus uv prime. We're going to get there. Let's figure out what v prime is. 2x squared. Let's swing the 2 to the front. 2 times 2 is 4. And drop the power by 1. So it goes from a power of 2 to a power of 1. Well, x to the 1, again, that's sort of redundant. We can just say x, right? 4x. So the derivative of 2x squared is 4x. Okay, here's how the product rule works. It says we can derive this if we follow this pattern. V u prime plus u v prime. Let's plug it in then, if that's our pattern. What's v? 2x squared. What's u prime? It's 1 plus u, that was x plus 1, v prime, that is 4x. And that is our answer. Now I know we can simplify that a little bit. So let's 2x squared times 1, that's just 2x squared. So we don't need to have that extra 1. Plus, let's do a little distribution here. Make this look nicer. That would be 4x squared plus 4x, right, if I simplify. And of course that actually even simplifies down, right? We have 2x squared plus 4x squared plus 4x. So my final answer would be 6x squared. We combine these. So the answer is 6x squared plus 4x. The end. Whew. Now, some of you are probably thinking, that was a lot of steps for something I could have probably just simplified. I could have distributed the 2x squared at the beginning and just use the addition rule and saved myself all those extra steps. And if you're thinking that way, you're thinking like a mathematician. That's okay. You're right. That might have been a faster method. But I'm giving you a really easy example right now. Most of the time when we need to use the product rule, we're using things like sine of x and tangent of x that we might be multiplying. And I will assure you that the product rule is going to be really awesome and really handy in those moments. With power functions, it's a toss-up. Sometimes the product rule is helpful, sometimes you can solve it a faster way. In math, there's 2 things we really care about. One is accuracy, obviously, you want to get it right. And 2 is efficiency. I know that sometimes we don't always lead you to believe that as math teachers, but in the real world, efficiency matters. So I'm giving you a toolbox of rules and patterns, but you do get to choose in each situation which tool is going to get the job done fastest and still give you the right answer. Those are always accuracy and efficiency are allowed to try make sure all your work is passing those two tests. But still, I'm going to stand by my example because I think this one helps us to see how the product rule works, at least at this point. We're not quite at talking about trig functions yet. Okay, look at all that crazy work. Let's clear this. You can pause the video if you need to write it down. But let's use that same function with the quotient rule. Well, we're going to have to make it a little bit of a different function. In the previous one, we just made we said we were trying to find the derivative with respect to x of x plus 1 times 2x squared. But now I'm going to say, let's find the derivative of x plus 1 divided by 2x squared. I'm still going to need to figure out what u and v are. Remember, u and v are, let's go back here. U over v. That means we have two separate expressions in terms of x that are basically creating a fraction, or we're using division. In this case, everything up in the numerator is u, everything in the denominator is v. And again, I always set up the same little chart here, u equals v equals, u prime equals v prime equals. I'm going to quickly write this in because we already solved this. We already figured out the same information in the last one. We said u is x plus 1, v is 2x squared. The only difference now is we're dividing instead of multiplying. We know that the derivative of x plus 1 is 1. If you don't remember why, you can look back. And the derivative of 2x squared is 4x. How does this work with the quotient rule? Well, the quotient rule says you can find the derivative of two functions that are being divided using vu prime minus uv prime all over v squared. And yes, you are going to want to memorize these. So vu prime minus u v prime all over v squared. Let's just plug it in. All right, we have v is 2x squared. U prime is 1. I'm just going through here, just to make sure you're following with me. Minus u times v prime. Well, u is x plus 1. V prime is 4x. And this is going to be all over v squared, which is 2x squared squared. And from there, we just simplify it. Now, I'm going to see I have limited room, and my point here is less about the simplifying and more about the formula that we're using, or the product, or the quotient rule. 2x squared times 1, that's just 2x squared, minus, this is really 4x squared plus 4x, but this is in parentheses. And in the denominator, this is really just 4x to the fourth. So what I am getting here, and again, I'm sorry for there's very limited room, and I mostly just want you to see how this comes down to a nice answer. We're going to have 2x squared minus 4x squared, so that's negative 2x squared minus 4x all over 4x to the fourth. That's squeezed in there. And that is the answer to the derivative of this function. Okay, let's review what I just said because I've got a bunch of colors here all over the place. When we want to take the derivative, and by the way, if this is bothering you, yes, that can be reduced a little bit, but quite honestly, I do not have room on my sheet for that. So we're going to leave it, pretend that's our final answer. If we're taking the derivative of two functions that are being divided, we do not need to use limits. We do not need to use crazy, that would not be fun to do that one with limits. Would you agree? Somebody has gone before us, has established the pattern as a rule that we can now follow. We call it the quotient rule. You identify u, you identify v. You create this little box of values, uv, u prime, v prime. And then you plug it into that beautiful formula, vu prime minus uv prime all over v squared. And that is it. Let's go back to this before we end. Product rule. U times v, v u prime plus u v prime. Quotient rule, derivative of u over v is vu prime minus uv prime all over v squared. And I want you to say that to yourself in your head or out loud, whatever works for you, or write it a million times. Whatever it takes to memorize it, you have to know those two formulas. They're really, 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 really important, and you're not going to get a note card, and it's going to make your life crazy if you're trying to constantly find that in your notebook somewhere. And so those are two important ones to commit to memory. We are going to be practicing these a lot in class. So if you feel like you need to see this a few more times, you can breathe easy. This is just an introduction. We'll see how this really works with some example problems during our class time. All right, that's it for lesson 3.